In this video, we'll learn about data types in C++ and see some more C++ programming examples. So there are slides up here that you can use as a reference, and I'll just go through. So first, let's go back to the first hello name file that we looked at in the last video. And so we notice one thing is we have this string data type in C++. And so this is kind of exciting where we don't have to, like, in C, we had to do something like declare a char array. It would be something like name, and we'd have to know how long it's going to be. Maybe we say it's going to be 20 characters long, and we're going to have to keep track of like the name length or something, or basically we have to define how this string is actually stored. But in C++, this is hidden from us. There's a string class. We can just make ourselves a string object called name, and if we go back to this slide, we see we don't actually know what's happening underneath the hood. I mean, we can assume maybe that there is a char array under there, but it's hidden from us. So we have a string data type. That's very convenient to work with. And one thing we might notice if we run this, let's just run it. I'll run my make, and then I'll run process. And if I put in like my full name, say, it's only going to pick up the first thing that I put in before the white space. So that's exactly like we saw with scanf. So if you remember, in regular C, our scanf would only pick up the white space. Before white space. Same here. So if I wanted to have both my first name and my last name, I think we got a slide for this. We could implement it like we see here. So say I have not just a name, but my first name, and say I also have a string last name, and now I might do something like enter first and last name, and now I'm going to get a first name, and I'm also going to get a last name. And then now if I want to print both of these, so we have a different way of doing our sort of string formatting. So we noticed we had to put this space in front of our name variable, right? So now maybe I put my first name here, and then I'm going to need another space, and then I can put my last name in, last name, and then I've got my ending my line here. Let's just see if I did anything different. Oh, okay. Actually, I did do something different. This is exciting. So first, okay, we could see if this works. And so that approach works. In the slides, helpfully, they actually were showing us how, for strings, the addition operator is valid, right? So I could also do string full name, right? I'm going to make my full name here, and I'm going to say full name equals first name plus, and then I think we need a space, plus last name. And then now to change this, here I would just say full name instead. And let's see that this works. Try that. So here we see that, again, the string is taking care of a lot of, is allowing us to be sort of more concise in how we actually accomplish what we want to accomplish, right? We can use our plus operator. We can just put these three strings together. And it looks like I could also have potentially used just the single quotes here, and that might have worked as well. Oops, I messed that up. Okay. Yeah, so I could also have used the single quotes there. So I have some more flexibility. So as you might expect, we also have integers in C++. So say I also wanted to get the age. We can also see that there's a more concise way of getting my input. So let's say now I just want my first name and I want the age. So I'm going to tell my user to enter first name and age. And now, so I wrote it on two separate lines, but I can also just say consume this first name and then consume the age. And then I don't need to make my full name anymore. Now I could say hello to my person with their full name, and then maybe I say something like your age is, and then I'm going to put in my age. And now let's make, and first name and age. My age is 30. So hello to me, my age is 30. So you notice that age is an int and fname is a string, but unlike in C, we're not having to put in our, specific placeholders. It's just able to work with these data types that we're passing in order to print them out. So we've already seen that we can just apply these same operators to different data types. And the type of the variable that we're applying the operator to is going to determine what actual behavior happens. So if I write cin and then I follow it with a string data type, it's going to read in a string. If I have cin and I follow it with an int data type, then it's going to read in as an int. We already saw we could use plus to concatenate strings. If I take two strings and I put the plus between them, it acts as a concatenation operator. But if I put plus between two integers, it would act as an addition operator. And this is called operator overloading. Very, I think, convenient and makes for, I think, very readable code, which is nice. And on these slides, there's some additional information about how different operators are overloaded depending, and so then their behavior depending on the type of the variable. So you can take a look at this if you're interested. So just like in C, we can do arithmetic using C++. I think maybe the most interesting thing here is this square root function is not just doesn't come with our C++ unless we use the CMath library, I believe it is. So maybe I would Google that and we can see how. So indeed it's CMath. Oh, it's already telling us maybe square root's kind of the most common one. But if I need CMath, I put in this header, and here we can just see all the different things in here. And so if I wanted to do something like, maybe for some reason I want to make age into the square root of the age, then I can include CMath here, and let's see if this helps us. Okay, it does. And I guess we could, did I write? I think I did right. Now let's try making it. We're not going to see anything, but it does run. And so one thing we can see is if oops, I forgot to go into insert mode. Where am I? Insert mode. So I'm commenting out this using namespace std, and now we can see that we're gonna have some issues. So if I didn't have this, I would, if I forgot, so if I say I forget to include this, then I think I'm gonna need to say I want string from the standard namespace, I want cout from the standard namespace, cin from the standard namespace, and now let's see. Oh, yeah, and my end of line character, end of line thing here is also, so now, oops, yeah, okay. So that's just a demonstration of why we put this in our code, and now we don't need any of this. So we'll go through and delete it again. All right, and then jump to the end. Okay. Okay, let's continue with our slides here. So here we can see simple computation, but a more complex program than more complex C++ program than we've seen. So I think we actually have this. Let's see. I'm going to copy. So maybe I'm going to remove hello name. And I'm going to copy from public intro, oh no, public examples, C++ intro, and let's take simp. Sure, that looks like it's going to be the right one. Okay, so I think that we have here the same thing that we've got on the slide. So we can just start to see some of the constructs that we've used in C. So we've got const. So we used const when we were inputting arrays to our functions, but we can also just use it if we want to insist that a variable doesn't change. So here this is just saying centimeter per inch should be 2.54, and this should never change in my program. Before we were using preprocessor directives to kind of create constants, but this works too. Here we see our while loop pretty much has the same, or has the exact same syntax as it had in C. And then again, our our output, our input, and then here we're just doing that. So our user is going to give us a length in inches, and we're going to tell them what it is in centimeters. So maybe let's take a look at what this looks like when it runs. Let's say it was 12 inches, then that turns out to be 30 centimeters. And I can keep going. I think, what was it, until they enter 0? Yeah. Okay. So there are some built-in types. We won't go through everything here, but you're definitely going to need your string. We actually have a Boolean type in C++, which we didn't have in C. We got our char, we got our int, we got our double. Complex is for complex numbers. And these are what is a char, things like A, X, new line. So there are provided types, and then we can also define our own new types. So in C we saw structs, in C++ we can define classes, and then the standard library is where we get things like string and vector. We will definitely get to in this class. So just like in C, we need to declare our variables, and we can also initialize them at the same time. And so at this point, we can kind of transition from thinking of variables to thinking about objects, because in C++ we don't necessarily know if our data type is one of these sort of basic types like an int, or if it is actually a class like a string, right? A string, we can kind of see this illustration is telling us that the string is not just a literal, it's not just like a 7 in there. There's some extra stuff going on. We have, this looks like our length. We've got a pointer to what's probably a array of chars, and our string s is going to have some methods. So we can actually think of what we create when we create objects. We can think of that way. So there's this idea of type safety, which is that when we create an object, we will only use it in a way that goes along with its type. In C, it's very flexible, and so we can definitely violate type safety. So one thing that so in general, we don't really want to be using variables not according to their type. But we can see, okay. So these are type safe operations here. Let's see. A is an int. It's set to 7. Now here we're setting it to 9. And now on this line, we're setting it to A plus A, so we're just adding 2 ints together. Here we're incrementing it by 2. And here we're incrementing it by 1, and we can see the values as it goes. So these are all type-safe operations. On the other hand, we can see an example of violating type safety with this little C++ program. So why don't I grab this? I'm going to get rid of the stuff I got going on here, and I'm just going to copy over the not from my home, but from public examples, C++ intro, and I don't know what this one is called, narrow, so maybe narrow.cpp, oops, and then I want to just copy it. So now I'm going to take a look. So the idea here is first, this is a big int, but not too big for an int. Big, I'll say relatively integer, right? And then char, if we remember, I think char is an integer data type, but it goes from, and hopefully I don't get this wrong, but I think it's -128 to 127. And so then here, okay, now I'm creating, so I guess the point being, well, now I've set this char to something that kind of doesn't really make sense. It's really big. It's too big, and so we call this narrowing, because I'm taking this thing that is too big and I'm putting it into something that it can't hold something that big. And then I'm sort of turning it back into an int. I have b here is an int, and it's going to be assigned to the value of c. And so you can see this is all, both of these lines are not type safe. I'm not respecting the type of my objects. And then, if I sort of just traced my equalities here, like if this was math class, if A has some value, C equals A, then in math class, B should equal C, right? But we're going to see that A and B are not equal. This is not math class. So if that happened, we would see this message, but we're going to see this other message. So let's run this. First compile it. And indeed, so we got 32 as our answer. So was it 20,000 there? So let's try this. Just if we want to sort of understand what's happening, if I increment this by 1, so we had 20,032, and now I'm just going to do, I added 1, and now we can see it went up to 33. So basically it's just wrapping around however many times. So when I add 1, this goes up by 1, but the point here is that the compiler, we're using the -wall flag here. The compiler is not complaining, but when we're programming, we do want to respect type safety, and generally C++, the compiler is going to try to enforce this for us, or it'll be enforced at runtime. So there's some additional information here that I will sort of say is optional for this class. I guess we could talk about this. Just another sort of thing to understand types is just that in memory, all we have are bits. They're zeros or ones, and it's only when we give a chunk of memory a type that those bits have meaning. And when we're writing our C++ programs, we can just think about correctness and simplicity of our code. And there are the built-in types in C++ actually going to help us out a lot. And here are some ideas about developing your program. And I will let you take a look at this on your own. There are standards that are updated for C++, and I think we have C++ 14. Actually, yeah, I'm sure we do, because we have this auto type. So what auto does is it's going to detect the type of our object based on the thing that we initialize it to. So if I say auto x equals 1, I'm assigning 1 to the variable x, and C++ will automatically give x the type int. Same thing for chars, for doubles. This is interesting though. If we say auto and we assign a variable, say s, to this string howdy, so this is, and maybe this will help kind of, why are we talking about objects versus not, like, what's that difference? So there's a string literal, that's just this actual string, but our string object in C++ has maybe additional data, like the length of the string actually as an attribute, and it also has methods. But the string literal has no additional data, it has no methods, it's just an array of chars. And this would give us an error, and auto even works when we are assigning the result of a function, not just these literals here. And I think that we have made it to the end of these slides.